Hi friends, welcome back to our new video, and this will be the last video on this topic. Today in this video I will try to conclude Modbus RTU Slave implementation by sharing with you the Modbus write operations and finally end with the Modbus serial line diagnostics. I have implemented, tested the microcontroller code and shared you the complete project on GitHub website. Given in link is given in the description. Now coming to the write operations related to analog values are done using holding registers, and whereas for the discrete signals is done using the coils register. Holding register write operations are performed using function code number 6 and function code number 16. Modbus master chooses the function code of its choice. So as a microcontroller implementation, as a Modbus slave, we have implemented both the function codes. So we have the feature. Similarly, for coil write operations are performed using function code number 5 as well as function code number 15. Now, this slide onwards, I will show you the flow diagram only for all the write operations. Okay, as I said earlier that I have configured, tested all the Modbus write function codes, so won't go deep into their operations, the C coding. I will request you yourself to start debugging the code which I provided you. Try to modify it, try to add more features into it, and try to minimize the response time. Because now if suppose I tested, it takes around 0.1 second or 0.2 second. If you can minimize that time, well, it will be a good achievement, because optimizations are the most time consuming task. So the first four blocks of the conditional diagram are same, means we start with while loop, we check once the timer 7, that T3.5 timer is expired, we recheck the CRC, and finally check whether the data is received to me or is it a broadcast address. Then thereafter we check with the function code, we check with the data limits of the data and also limits of the registers. So that happens for all, and again this diagram is not invented by me, it is given in the Modbus application layer protocol. So I request and recommend you to visit modbus.org to study all these documents, which will be very useful for designing anything of your choice. Next comes the force single coil. Sorry, in the previous slide, first we started with presetting of single register, that is function code number 6. Next is the preset multiple registers, so function code number 16. Next we will check force single coil, that is writing only one single coil, and this is the block diagram. And finally force multiple coils, that is function code number 15. Don't worry about this block diagram. If you face any issue understanding this block diagram, please comment in the comment section. I will definitely help you out. Next, finally, we decorate our Modbus project with the serial line diagnostic managements. So we have so many diagnostic counters. Again, these counters are not invented by me. They are given in the serial line implementation. So that is also a part of the Modbus standard. And this is applicable for serial line only. If we are using TCP IP, then these counters are not applicable. And now since we have completed all the implementation, so we will discuss an overall flow, like how the program in STM32 microcontroller is happening. So we have two C files here on this slide, main.c file and the another file, the STM32G0XX_IT.c. This is the interrupt file. Here you can see zigzag arrow lines, so this represents the event. like this won't appear in the flow, it can appear anytime. So in the coming to the main.c file, we initialized all the peripherals of the microcontroller which are applicable to the Modbus slave implementation. Finally, we called the Modbus initialization. This is a uh, custom C function written for our microcontroller. And on the right hand side, as I said, these are the interrupt function routines, and the function is written, their functioning is written below the blocks. These interrupt routines will be in your, if you are using some another microcontroller, it will be in your microcontroller also. The operation has to be same, only the implementation on ground for your microcontroller it will be different. And I did using STM32. For this is the syntax. For if you are using atmega 328, the syntax something will be different, but again the functionality, the principles, the fundamentals remains constant. In the next file, I am trying to explain you the C file mb processor.c. We started with mb initialization function, then the check mbpdu. This is the main processor function. So once the timer t3.5, that is timer 7 in this example, is expired, then that calls check mbpdu c function, and inside that c function we recheck the crc. And after the crc is verified based on the function codes, we call various other c functions, like for function code number 1 and 2 we call mb process bits read. For function code 3 and 4 we call mb process register read. So in the same way, based on the function code number 5, 6 and other function codes, all these C functions are created, tested by me. I would insist again that you to test this code once into your microcontroller. Even if you are doing it for any other microcontroller and you are facing any issue, please definitely comment me. We need to understand the basics. Next, again, as I've been saying that you can implement this Modbus slave protocol on any other microcontroller. So I have just listed the steps what can be done if you are implementing, say using some Texas Instruments microcontroller, or using PIC microcontroller, or using 8051, anything. So these are the steps given into the as a generic steps. Okay, I hope this will help. And finally, I would like to thank you for watching and supporting me through your views and likes. This means a lot to me and encourages me to learn many more things. And I hope this will also, I am trying my best to transfer my learnings to your understandings. Now the intention to create this series was just to start with the microcontroller coding due to COVID lockdowns and doing work from home. So I just thought of learning the microcontrollers which I left during my college project days. So with that inspiration gave me to start this series, and I hope I'll come with a new video on a new topic. So stay tuned, keep learning, like the video, share and subscribe my YouTube channel. Thank you very much.